Welcome to STEM Baba. In this video, we'll discuss the conceptual questions of chapter 4 from the book James S. Walker. Now, we have completed the chapter 4, two-dimensional kinematics. Now we'll discuss the questions from the book James S. Walker, its 5th edition. Okay, the first question says that what is the acceleration of a projectile when it reaches to its highest point? And what is its acceleration just before and after reaching this point? It's pretty simple. All the time the acceleration on the projectile is acceleration due to gravity, which is always vertically downward. So A, we have G and the direction is vertically downward. So this would be the solution. Now in this question it says that a projectile is launched from the level ground, and when it lands, its direction of motion has rotated clockwise through 60 degrees, and we have to tell the launching angle. So suppose that a projectile is launched with some angle theta. We don't know this angle theta, but we have to tell. Now when it lands, it will land like this, and this angle will be same theta but below horizontal. This is the symmetry of projectile that we studied. This angle theta will be same. It is theta above horizontal. This will be theta below horizontal. Now it says that the direction of motion has rotated 60 degree clockwise. So this angle theta has rotated 60 degree clockwise. So what should be theta? Think. Now if this angle is 30 degree, so this will also be 30 degree, and the change in direction will be 60 degree clockwise if this is 30 degree, and that proves the statement. So the launching angle should be 30 degrees. So in this question it is given that a projectile is launched with an initial velocity of this thing, and we have to find the velocity of the projectile when it reaches to its highest point. Now let me first draw the coordinate system. So this is our coordinate system. This is positive x, positive y. Now we studied that the trajectory of the projectile motion is parabolic. So the trajectory for this projectile will look something like that. It's a parabolic, and it's the highest point of the trajectory. Now it was launched with some initial velocity, so this will be its velocity vector at the initial point v, which we are given to be this. Now at this point we know that the projectile moves horizontally, and there is no component of velocity in the vertical direction because the gravity has reduced its y component of velocity to 0. Therefore at this point the projectile have only the x component of velocity, which is 4 meter per second. So at this point the velocity of the projectile will be 4 meter per second x cap. This component goes to 0 at this point. So this would be the answer for this question. So in this question we have to tell, do projectiles for which air resistance is non-negotiable? Means we have to consider the air resistance, and then in such cases is the maximum range is achieved when the launch angle is greater than, less than, or equals to 45 degrees. This is what we have to explain. Now in such cases where air resistance is non-negotiable, to obtain the maximum range the launch angle should be less than 45 degrees. This should be less than 45 degrees. So when I was discussing the concepts of projectile, I discussed one topic called projectiles with air resistance, and if you haven't seen that video, click on the bell icon. There I discussed one graph, and this was the graph. It shows the range of projectile with same initial velocity but with different launch angle. This is when theta is 15 degree. This is when theta is 25 degrees. This is for theta equals to 35 degrees. And this is for theta equals to 45 degrees. Now here you can see that the maximum range is achieved when theta is 35 degrees. And the reason is that for smaller launch angle, the projectile is in the air for the less time, giving air resistance less time to effect its flight. Thus, where the air resistance is non-negotiable, in such cases the projectile should be launched with less than 45 degrees to have the maximum range. So here we are given that a child rides on a pony walking with a constant velocity in one direction. Now the boy leans to one side and a scoop of ice cream falls from his ice cream cone. And we are asked to describe the path of scoop of ice cream as seen by the child and by his parents standing on the ground nearby. Now, from the child's point of view, it falls straight down. So the answer for the A part will be straight down. But from the parent's point of view, the scoop of ice cream has some horizontal velocity and also the acceleration in the downward direction. So this case is similar to the projectile motion with uniform acceleration in one direction and constant velocity in the perpendicular direction. So for projectile motion, the path is a parabolic. So from the parent's point of view, the path will be parabolic. So here we are given that a projectile is launched from origin, this is origin, with some launch angle, and when it reaches to the highest point, the direction of motion has rotated clockwise through 50 degrees. There are two parts basically in this question. We're going to solve the A part first. So in the A part it says that it had rotated through 50 degrees clockwise. Now one thing we know, when the projectile reaches to the highest point, it moves horizontally. Thus we can conclude that the projectile was launched with the initial launch angle 50 degrees such that when it reaches to the highest point, it moves horizontally. That means it had rotated 50 degree clockwise, and thus we can conclude the answer should be 50 degrees above the horizontal. So for the A part, the answer will be 50 degrees above horizontal, like this, as you can see here. Now next, in the B part, it says that this time it had rotated counterclockwise through 30 degrees. Now in this case, it should have been launched like this, and this angle should be 150 degrees. Why? Because when it reaches to the topmost point, it had rotated counterclockwise through 30 degrees, so it would rotate it like this, and this here at this point it becomes horizontal. So 150 plus 30, it becomes 180 degrees. That means it becomes horizontal at this point. Thus we can say that the projectile is launched with 150 degrees from the positive x-axis, or you can also say that it was launched with 30 degrees above the negative x-axis. We can represent this way also.